Hello, welcome to the second in the series of videos which should help students prepare to study A-level computer science at the Campion School. This one's on input, output and assignment, which are absolutely fundamental to writing any computer program. Assignment is simply just storing stuff in the computer's memory, which don't forget is temporary, it's only there when the computer's running. And input lets you interact with the user, output lets the user actually see what's going on in the program. So in this video you should be able to choose a sensible data type by the time we're done. This might be new to you, but there's a bit of a discussion to be had on that, so we can have a quick look. We're going to learn how to display data on a screen, which we've seen, but we'll learn exactly what's going on. And we're also going to learn how to take user input and store that so we can use it later on in our program. We're going to look at some really simple mathematical functions, and we're also going to look at and touch upon writing clean code, which would be things like keeping your code nice and tidy, but also using comments, because that's going to be probably the main way that your technical ability and the complexity of your system is going to be assessed in your coursework project, the non-examined assessment, which does count towards the A-level. It's not like the GCSE of years gone by. So let's move into Visual Studio so we can start learning about what we're going to cover in the video. So Visual Studio, when you first open it up, it's going to look like this. We've got recent files that you've had open. We had Hello World open in the last lesson, so that one's there. We can open that again if we want to continue working on it. I'm going to create a new project because this is a new topic. Remember that you're going to be using console applications at the moment, and they need to be in VB because that's the language we're using. You can't use C#, not for these tutorials anyway. It's not going to understand the code. It's like speaking to somebody in Russian and them not understanding because you're speaking English. Okay, so let's take VB, let's click next, and we need to give it a project name. And remember the location where it's going to get stored. It's going to be put into that repos folder. So let's call this one, I guess we can call this input output. So that's what we're going to be looking at. And then we can just go and click create. Remember, it takes a couple of seconds to actually build the project. We'll have a look in the project folder this time as well, so we can actually see what's going on. And we've got our program. So I'm actually going to tidy this up a little bit. The first one I'm going to do is I'm just going to delete the console right line hello world. That's just there, just as a bit of a placeholder. And I'm also going to delete this bit that's between these brackets, args as string. Okay, we haven't actually got any arguments to put into there. We haven't got any parameters to put into these brackets. I'm going to explain what that means now. Firstly, you need to remember last time I told you everything's going to go between sub main and end sub. Sub main is just a subroutine. Now, it's a subroutine of the module program. Anything, I've got the white theme, remember, so mine are like a sort of a teal, greeny, cyany colour. These are objects. Anything that's got that colour in is an object. So program is an object and it's a module, and the module is made up of several routines and data. Okay, at the moment I haven't got any data. I've just got one routine, which is the main routine. Now, if you have a look at the Solution Explorer, you can see I've got that file there, program.vb. Program.vb is the file we've got open at the moment. It's the module for program. Now, if you try and expand that, you can see it's made up of only the main routine, main open bracket, close bracket. Now, we're not going to look at subroutines for a few videos yet anyway, but for now what we need to know is that's going to be the first thing that gets executed in our program if we had other routines. So previously you might have seen programs start on line 1, then they go to line 2, then line 3, and then we might have a loop and it might jump back to a previous line and it might go down to a line in the future at some point. Okay, but what we're going to say is the sub main, the routine called main, is going to be the first one that gets executed no matter where it is in the program. So at the moment it's on line 4. If it is on line 1004 and I've got loads of other routines that come before that in the program, it's still going to run that one first. Okay, so sub main is going to be the main bit of the program, and actually I want most of what you do for now anyway to take place in sub main. So let's just put into sub main our main bit of code that we're going to be working on. So we're going to start by we're going to build a little calculator. So we're going to store a couple of numbers. We're just going to add them together or do some operation on them and then just output the value. So let's do add to begin with. So this is where it's going to differ a little bit from what you might have seen in other languages if you've looked at Python or any other type of language. Normally you can just start typing out a variable name and it should just work straight away. So number1 equals 5, for example. Now I've got a red squiggly line. So if you put your cursor over your red line, or the part of the code that's got the red line, it will actually tell you why it's come out of a red line. A red line is bad, it means there's a bit of a problem. Okay, number1's not declared. What does that mean? Well, in VB and in other languages like C, okay, we need to declare our variables before we use them. That makes space in memory for them, and it actually can make your program more efficient, because not only do you declare the space in memory, not only do you make the space in memory, you're also going to say what type of data it's going to be, and it can put aside just the right amount of memory for that piece of data. So number1 is going to be a whole number. We need to differentiate between whole numbers and numbers that might have a fractional part, which we call real numbers. Okay? Integers are what I'm going to use to refer to a whole number, even though integers are also real numbers. If we're only working with numbers that are going to be whole, it's actually much more efficient if you use the data type integer for that. If you think back to how binary works, you've probably only ever learned to represent whole numbers using binary at this stage. So that's the difference. The numbers that are integers are just a lot easier to store in memory. They require less memory, they require less storage, they require less processing. Therefore our program can be more efficient. We're always going to try and write really efficient programs. So for now, we'll just say that all integers are integers, but in the future you can start using integers that use less memory. So if you know that your number is only going to be small, it's not going to go above like 100, you can then just use a piece of data that can only store numbers between, well, it would be 0 to 255 would probably be the most efficient way of doing that. And you will get more marks in your programming for using more efficient data when you come to do your coursework. So to declare a variable in memory, we want number1, and also we want one called number2. So I'm just going to write that one. Notice that because I started typing out, I started trying to guess what I was typing, and because I haven't actually declared number1 and number2, it didn't know what to do. So number1 and number2 don't exist. Let's declare them. Declaring them is really easy. Just at the start of the routine where you're going to use them, we're going to use it in the sub main routine. So just somewhere immediately after that line, I'm going to write dim. Now dim, the easy way to remember that is declare in memory. It doesn't actually stand for that, but it just makes the space in the memory for these values. So I'm going to say number1, and as you can see, number1 has now lost its red underline. So number1, and if you press space, you need to declare a data type. In fact, it'll work without a data type and it'll just guess it for you, but it's always better if you use the correct data type. So if I type as integer, number1 is an integer. Okay, if we put our cursor over integer, you can see what it describes an integer as. So an integer is a 32-bit signed integer. Signed just means that it's got the ability to be negative, i.e. it can have a sign. 32 bits, if you recall how binary works, it just means that the number can be represented using 32 binary digits. So it doesn't actually go up to like 0 to what you would expect, which would be 1 less than 2 to the power of 32, because it can be signed. You'll cover that on the course how that works at the moment, but you can get a very big number. If you need a bigger number, there are other data types, so you can do int64 for example, but if you're not going to be using data that's that large or potentially that large, you're wasting memory. So let's just always use integer for now. So let's also declare number2 as integer, and then let's also declare dim sum as integer. Now notice sum has got a green squiggle under it. If I put my cursor over that, it just says it's unused. So green isn't necessarily bad. Green just means, do you know what, you might have used a piece of, you might have declared some data here that you've not actually used, that's a waste of memory. You can just delete that safely and your program will still run. So that's handy for you to see, but we can use that for now just to remind us that we need to assign something to it. So assigning, we've actually done that twice already. Assignment is just this use of this equals sign. Okay, what we're literally saying on line 10, we're saying put the value 5 into number 1, put the value 7 on line 11 into number 2. What do I mean by put? It means store it in memory. Memory works as I've heard it described before as a bunch of buckets which you can just put things in. Yeah, that's quite a nice analogy. I quite like that. But the buckets have got numbers. Now the numbers are massive, because if you think about how much memory you've got installed on a computer, it can get quite large. It's like gigabytes of data. So there's massive amount of space which put the values into these buckets. So the buckets are really difficult to remember the numbers of. So what we do is we just give them a name in our program instead. So actually, this line here, dim number 1 as integer, what it's doing is just saying, you know what, you've now got a value called number 1, and when I run the program, it's going to assign it some space in memory, and I don't need to know where it is in memory. I don't really care where it is in the memory. All I know is I can get that back by referring to it as number 1. So put number 5 into the memory called number 1, put number 7 into the memory called number 2. So if I want to get the sum of these two values and store it in the value sum, you can probably guess what's going to happen. Let's go sum equals number 1, and I can just do plus number 2. Now if you look, nothing syntactically wrong with that, because I haven't got any red underlines. It looks like a maths expression written backwards. Number 1 plus number 2 equals the sum. Okay, it is that, but because we're assigning that value to sum, it's almost like we're writing it backwards. So sum is going to be set to, that's how you read it, sum is set to number 1 plus number 2. So if I now do console dot write line sum, I should be able to run that program, and we see the value 12. So that program's worked. Number 1 is 5, number 2 is 7, number 1 plus number 2 is 12, store it in sum, and then print the value sum. Okay, that's a really simple program. Now what we could do, we could take these two numbers and we could ask the user to input a value into those two numbers instead. So what we've done is we've just assigned the number 5. Every time I run that program, the number 5 is going to be assigned to it. That's boring. We don't want to see that happening. Okay, so what I'm going to do is I'm going to say number 1 is going to be console dot rather than dot write line, I'm going to do read line. So number 1 is going to be set to console dot read line. I'm actually just going to copy and paste that onto that there. Copy and paste things. If you've got blocks of code which work, just copy and paste them. It reduces the opportunity for you to make a typing error. Okay, so read line takes user input. You're going to see what it looks like in a second, but what we're going to do is we're going to let the user type something in, and they're going to store it just like we did before in number 1. They're going to do it a second time. It's going to add those two values together, and then I get a little calculator which is called sum. Okay, so if you run the program, you will see that actually this looks like just a flashing cursor at this point, and nothing's happened since. Okay, that's a bit odd. So what we're going to do is we're just going to type in a number, because we know the program says, well, when I get to line 10, I'm expecting the user to type something in. So let's type in number 10. Then the cursor moves to another line, so it's going to say, let's type in another number. Let's type in number 20, and then the program actually jumps quickly to the end, but before it gets there, it outputs the number 30. So the number 30 is the sum of number 1 and number 2. So we know line 13 is actually executed there, and so is line 15, because we can see it on the screen. Okay, if I took out line 15, the program's just going to jump to the end, and you won't see it output. So we always need to be outputting to the screen so we can actually see what's going on. And if anything, you probably want to put too much output into it, because you can always remove it to tidy up the program after you're done. Okay, So that is a program which is really, really straightforward, but has declared data. At the moment we're only using integers. Okay, we'll look at data types another time, probably in the next video. For now, we've got number 1 is going to be set to read line. Number 2 is going to be set to read line, so they are user input, both of them. Okay, and then we're going to say that number 1 is going to be added to number 2 and it's going to be set to sum. Now, if I want to do something other than add, I need to use a different mathematical operator. On a slide here, I've just prepared a quick table which is on one of the tutorials which you can get from the school website. But there's the 4 mathematical operators that you're probably most familiar with: add, subtract. The only 2 which are a bit odd because the x just looks like it could be a name of a variable called x. The star we use for multiply, or the asterisk is the proper name for it, and then a / for division. There are 2 more. There's actually a backslash which returns only the whole number part of it, because we're working with integers anyway, we don't really need to worry about that. And then there's another one which is called mod, which returns the remainder, which is probably the most useful one out of all of them, but you'll look at that again in the future. Okay, now if I were to change that to a star, that's going to multiply the 2 numbers together. Now, in terms of the program running, let's just do 5 and 10, and we should expect 50 to be the output, which it is. That's actually not a great name now for this variable sum. Okay, so sum probably wasn't ever a great name for it, because the program isn't always going to be sum. I know previously it was, but I've changed the parameters of this program now, so sum isn't a great name. If I were to come back to this in a year's time and I was going to start reading through it line by line, I'd look at that and I'd say, oh, do you know what? I've got a number 1, I've got number 2. I can see the input in number 1 and number 2, and then I've got something called sum. I'm going to assume at that point that they're going to add 2 numbers together. I've added 2 numbers together. Okay. On line 13, I haven't added 2 numbers together. Sum means add. A better name for that would be something like answer. Okay. Result, something like that. Notice that sum needs to change in both of those positions there as well. Okay. You must pick sensible names for your data. Okay. And when you make routines, you must pick sensible names for them. Certain names you can't use, like you can't call it main, because this is called main already. You can't call it program, because this is called program. Can't call it module, because that means something. Okay. You can't call it end, because that means something. Okay, but number 1 is meaningful. It's the first number that I'm going to input. Number 2 is meaningful. It's the second number I'm going to input. Answer is meaningful. It's going to be the answer. Okay. The second thing to jazz this program up a bit is when you run the program, if you gave this to your brother or your sister to run, they're not going to have a clue what to do. So we need to give the user some sort of prompt, some sort of guidance to say what they need to do. Whenever you write programs, you need to always just assume that you're going to be writing a program for the stupidest person possible. Okay, you need to give the user as much guidance as you can when you write these programs. So what I'm going to do is I'm just going to say console. But we know how to output, don't we? Console.WriteLine. Enter a number. Remember, when I put things inside speech marks, it literally puts that string, that piece of text, out onto the screen. Then I can just copy and paste that block of code into between there, and I can say enter another number, and then I can say the answer is. Okay, now if I run this program, let's have a look. It's now got a prompt for me. Enter a number 5, enter another number 10. The answer is 50. Okay, a better prompt would have been 5 times 10 is 50. Okay, notice that right line there, I haven't put the word answer inside speech marks. If I put the answer inside speech marks, watch what happens. You can probably guess what's going to happen. I have a guess before I show you. 5, 10, what's going to happen? The answer is answer. It literally writes out the word answer. I don't want to literally write out the word answer. I want to write out the thing that's stored in my variable called answer. Okay, now you can start joining the 2 different lines together. I know I showed you how to do that using write before. You can probably work out how to do that. You need to remove the line from there, but what I could do is I could actually just put it outside of the string inside this bracket still. So the string being that set of speech marks there. If I just say answer, the answer is answer. I need some way of joining them together, because you can see that it doesn't like the syntax of that. The way to join them together, the best way of doing it, is to use the and sign. Okay, the and sign is the best way of doing it. You can do it using a plus as well. However, you've got a number, you're trying to join it to a piece of text, it's not going to know what to do. So use the and sign, and that's going to say I want you to join these two pieces of text together. The answer is 50. Okay. Notice put a space there. If you don't put a space there before the close of that string, you're going to get the answer nudged right up against the string. It's not going to look good. So the last thing for us to cover that we said we were going to cover in this video was we were going to look at how to put comments into our program. Comments are really important. Like I said, if you were writing a really long program, or you would come back to this in a year's time, you're gonna struggle to remember what you've done. Okay, so what we do is we put comments in, and also if you're doing this for a job, you might move to a better job. You just don't know what's going to happen. Someone else might be working with you. You're probably going to be working in a team anyway. You just need comments there, so people just pass messages to each other. Comments in VB start with an apostrophe. Okay, the apostrophe, I'll just say declare variables. There you go, there's a comment. The next block of code is gather user input. The next bit is calculate answer. And then the last part, let's do display answer. There's 4 comments there, and they guide me through what I wish to do. In fact, what you can do is you can write the program out, if you like, in comments first of all, and then you can just add the code in before. That's actually quite a nice way of doing it, because if you take out the code, declare variables, gather user input, calculate the answer, display the answer, I've just broken that program down, I've decomposed it into the problems that I need to do in order to solve it. The last one I'm just going to do is I'm going to show you a couple more pieces of data. I will show you some more in the next lesson anyway, but things that you might want to see at this stage. If you declare like name as string, a string lets you assign name equals hello, lets you assign a literal string, this sort of clarity coloured text to it. This is what we've been using to output at the moment. So I can output name, and that lets you just access whatever line of text you've got stored in there. At the moment, you're probably just going to be working with integers. If you want to get a number which is fractional, so if you're just going to try some division or something, the easiest one to use now is dim. Let's just use number 3 as a single is the easiest one to do it as. So single is a single floating point number, single precision floating point number. It actually uses I believe it uses the same amount of data as an integer, but the range is actually, I don't think the range is as high, but the precision that you can get with a number is obviously a little greater, because you can start representing things that lie between the whole numbers. So I can get like 1.5. It's only singular in terms of its precision, because you can get a double as well. So dim number 3 is double. Uses more data, but it allows you to represent numbers more accurately. It's actually very difficult to represent non-whole numbers in memory using binary. So there's a couple of things that you might want to look at if you want to have a little play with this before you move to the next lesson. I'm just going to take this variable out here. But that is the end of what I need to demonstrate to you. So you've got declaration of data, you've got user input. Remember, you've always got to assign the user input to a variable. If you don't assign, it's going to move on to line 13. It's going to forget what the user typed in. So assign, pick a sensible data type. I've got prompts that tell the user what to do. Remember, you're always going to be programming for the person that's going to understand the program the least. Okay, programs need to be intuitive. Think of every time you've used a program that is difficult to use, you just stop using it straight away. Make your programs easy to use, and then comments. Comments let you see what you're doing. They also allow you to explain your code. That's very useful when you're going to come do your coursework project whilst you are studying. So I've got 4 exercises for you to try. You can pause the video now and you can have a go at doing them. So first one, write a program that reads in 3 numbers and outputs the total. Write a program that reads in 2 numbers and displays product. I think we've just done that anyway. But write a program that enters the length, the width and the depth of a rectangular swimming pool. Calculate the volume of water required to fill the pool and display this volume. Okay, so I'm not actually going to show you the solution to number 1 and number 2 because I've actually done number 2 as part of the demonstration that I did before in the explanation. So I'm going to jump straight into number 3 and then into number 4. So firstly, I'm going to do this properly, this one. So let's just delete what we've got. If we're going to work out the area of a swimming pool, we're going to need how many pieces of data? 3. So we're going to need the depth of the pool, the width of the pool, how long the pool is. Okay, so let's declare our data. So let's make a variable first of all. So declare data, let's say we've got width, depth and length. Okay, let's put the rest of the program in now. So let's calculate the volume, display the volume. Is that everything? No, we had to allow the user to enter the data. So that's going to happen before we calculate the volume, isn't it? So let's enter data for width, depth, length. Okay, so let's declare the data. See, writing out the comments first of all allows you to basically make the program a lot more simple, doesn't it? So we're going to have 3 pieces of data, aren't we? So dim width as integer, dim depth as integer, dim length as integer. Enter the data. So let's just do one of them and then we can just copy and paste them, can't we? So console.writeLine, enter the width of your pool. So to store the width, what I'm going to do is I'm going to say width is going to be set to console.readLine, really easy. Then what I can do is I can just paste that twice more. Put spaces in the program as well. The spaces make it easier to read. Okay, spaces, if you put the spaces in, it's just going to ignore them. Okay, but you can use them to make the program a lot more straightforward. I know that it automatically indents certain things, but the spacing is not a problem. Do it. Okay, so let's do length secondly, because that'd be weird if we did depth next, wouldn't it? So let's do length of your pool, and then finally depth, and to the depth of your pool. So to get the volume, I'm just going to multiply all those values together, aren't I? So I'm actually going to need a 4th piece of data, aren't I? So I can go back up the top, and I'm going to say dim volume as, it's going to be an integer because 3 integers multiplied together makes another integer. Volume is set to width times length times depth, and then display the volume. We can just do console.writeLine. The volume is, remember how we joined it? We used the ampersand or the and sign, and then we just write the name of the variable where that's going to be stored. So let's do the width of the pool. So my pool is going to be 10 metres wide. That sounds about the width of a normal pool. I think they're about 50 metres long, aren't they? And then the depth of the pool, well, how deep's the pool? 10 metres, I don't know. The volume is 5,000. Okay, there you go. That looks like it's correct, doesn't it? 10 times 10 times 50. So our program's actually worked. Now it might be nice if we can add on m cubed at the end of it. I know we can't actually write that on because we can't write the little tiny 3, but what we could do is we could add something onto the end of that. So we could just put another and to join another string to the end of it, meters, and then the generally accepted way of doing it is using this kind of little chevron there, which basically just means meters to the power of 3. So let's just try that again. 10, 50. Let's do like a really deep pool. So that's a diving pool that time. Okay, so the volume is going to be 10,000 this time. So that's nice, isn't it? That's a fully working program, all commented, and it's got loads of prompts for the user. Anyone would be able to come and use that program and get the volume of their pool. The second, or the fourth task, should I say, is to take the length and the width of a rectangle and get two different values back from it, the area and the perimeter. So, do you know what? I'm going to just adapt this program so it does it. So we've got the width and the length of the rectangle. Okay. This time what I'm going to do is I'm going to say enter data for width and length. Let's take depth out of there because that is a false comment. Otherwise, let's then calculate the area, and then let's also calculate the perimeter. Okay, and display values. So entering the data, let's say console.WriteLine, enter the width of your rectangle, and then the width is going to just be width equals console.readline. Oh, don't need a zero in between there. I haven't got any red underlined lines there, so everything looks like it's in order. Let's enter the length as well, and we'll set that to length there. Very good. So calculate the area. Area width times length. Okay, no problem with that. So let's also declare the two pieces of data that we need. So dim area as integer, and let's dim perimeter as integer. So area is going to be set to console. No, it's not. I lied. It's going to be set to width plus, no, it's not, times length. A few errors there. So area is easy. The perimeter, let's show off the way we do the perimeter. So the easy way to do the perimeter is just do perimeter is width plus length plus length. That is going to work and it's going to make sense, but we can start making that a bit more simplified. So we can use our orders of operation, our bidmus or bodmus or pedmus or whatever you call it. We can use that here and apply that here. So inside there we can basically say it's going to be 2 lots of width plus 2 lots of length. So we can do width times 2 plus length times 2. That expression absolutely makes sense, and it can be assigned to the perimeter. There's no difference to me saying width times 2 plus length times 2 equals perimeter, except this time I'm just saying do that, add them together, store it in the perimeter, and then display our values. So just do console.WriteLine. The area is and area, console.WriteLine. The perimeter is and perimeter. Okay, so that once again is a fully working program, fully commented. We've got data with sensible data types. It's nice and spaced out so we can read it easy, and it's got prompts for the user. So let's just prove that it works. Enter the width of the rectangle 5, enter that could be 32. So the area is 160, the perimeter is 74. That is correct. A very narrow rectangle, that one. One more thing I'm just going to show you. Sometimes I like to put little titles at the top of the page just to kind of make it a bit more jazzy as well. So the first one I'm going to do is just do console.WriteLine, and traditionally what we do is we do like a series of just hyphens. Console.WriteLine, let's call it the rectangle calculator. And then you can just copy and paste that block of lines there, and it kind of just frames the program a little bit more. It makes it look a little bit more interesting to use. You can also do this to make it leave gaps and things. For the console.WriteLine, open bracket, close bracket, that puts a nice little gap between there. Okay, don't worry about centering things on the page. we don't need to bother about doing that. You can do it if you really want to. You can probably work out how to do it yourself, but if you just stick everything over on the left hand side, you'll be a lot happier. There's one more thing I can probably show you at this point, actually, before we move on. Another little bonus. If I do console.readline at that stage, and I haven't assigned it to anything, that's sometimes quite handy to do, because I can actually leave it so I've got to press enter before I get the next instruction. If I did immediately after that console.clear and I run it and I press enter, it actually deletes what you'd put on the screen previously, so you can kind of make it so it's moved to a new screen. That's sometimes quite handy to do if you've got a lot of text on the screen beforehand, but obviously you won't be able to scroll back up to it because you've got the little scroller there, see. Make sure you put the console read line in before it, because if you don't, the program, you might have seen that happen, but it moves really fast, and it's just moved directly to that line there, because it's done line 13, 14, 15, 16, 18, which is cleared it all, and then we jump to 21, which is the first one that we can see because we haven't cleared that yet. Okay, so that is the second video. Hopefully you will continue on to the third one. Thank you for watching.